Ever try sharing a meme with your AI chatbot? Hoping for a good laugh, but instead it's just crickets.
Yeah, they're not great with humor, are they? Like, they understand the words but totally miss the joke.
Exactly. It's like they don't get it, and it really highlights those limitations of current AI, right?
Hmm.
They're amazing with text, but understanding an image or a video, that's a whole other ballgame.
And that's where these multimodal large language models come in, or MLLMs for short.
And that's exactly what our deep dive is all about today. We're taking a deep look at a recent research survey paper. It really maps out this exciting new frontier in AI.
This stuff is evolving so quickly.
I know, right? And this paper is like a guidebook. We're talking about AI that can process not just text, but images, videos, you name it. It's mind-blowing.
It really is. The paper we're looking at is titled A Survey on Multimodal Large Language Models. It's authored by a really impressive team of researchers from the University of Science and Technology of China, along with folks from Tencent U2 Lab.
Tencent U2 Lab, that's a name I've been hearing more and more.
They're doing some really groundbreaking stuff, and what makes this paper even better is that it's hot off the press, published just this year.
So we're not talking about some dusty old research here. This is the cutting edge.
Absolutely. But before we get ahead of ourselves, let's break down this whole MLLM thing.
Yeah, let's do that.
What are they really?
Yeah.
And how do they actually work?
In plain English, please.
Okay, so imagine an MLLM as having these three core components, all right? First up, you've got the modality encoder. Think of it like the AI senses its eyes, ears, you name it. It takes things like images, audio, and translates them into a language the AI's processing unit can understand.
So it's kind of like converting those real-world elements into like the AI equivalent of ones and zeros.
Exactly. Now, this encoded information gets sent to the pre-trained LLM, the brain of the operation.
Ah, so this is where those familiar names we always hear come in, like Llama or GPT.
You got it. They bring their language processing power to the party.
So that's where the AI really starts to decipher the meaning, connect the dots, build understanding.
Right. But there's this crucial bridge between those two components, the modality interface. This is where it gets really interesting. The modality interface is like the translator, allowing the pre-trained LLM to actually make sense of all that encoded information from the modality encoder. It connects the dots, so to speak.
Okay, so let's try to make this crystal clear with an example. Let's say we show an MLLM picture. Let's say a cat wearing a tiny cowboy hat. Classic meme material.
Perfect example. So the modality encoder would break that image down into its elements, the cat, the hat, the colors, and translate them into that AI-readable format.
Like giving the AI the building blocks to understand what it's seeing.
Exactly. But here's where the modality interface comes in. It's not enough for the AI to just process those individual elements. It needs to understand the relationship, the context. That's what the modality interface does. It allows the LLM to connect those elements and understand this isn't just a cat in a hat, it's a cat wearing a hat.
And that's when the AI can finally appreciate the utter absurdity and hopefully the humor of a cat in a cowboy hat.
Precisely. It's about moving beyond simple text-based AI. Now we're stepping into a world where AI understands the world more like we do through multiple senses.
So it's not just recognizing a cat in a hat, but understanding the hilarious juxtaposition of those two things together. That's wild. But how do we actually teach an AI to see in the first place? Like, how does it learn to process this visual information along with text?
It all comes down to training. But it's not as simple as just, throwing a bunch of data at the AI and hoping for the best.
There's a method to the madness.
Big time. The paper breaks it down into three key phases: pre-training, instruction tuning, and then something called alignment tuning.
Okay, let's unpack these training phases one by one. What's involved in this pre-training stage?
So pre-training, that's all about laying the foundation. We're teaching the AI the basics of associating different modalities, like connecting images with text.
Gotcha. So it's like giving a child a set of building blocks and letting them figure out how to put them together.
Exactly. The AI is soaking up a ton of general knowledge about the world during this phase.
It's like how the world works 101, but for AI.
Exactly. And the fuel for this crash course: data. Mountains of it. Captioned images, audio clips with transcripts, the whole shebang.
And I'm guessing a lot of this data, like it comes from the internet, right? Scraping every image and caption they can find.
You know it. Datasets like LAION5B, it's got billions of these image-text pairs. A gold mine for this kind of training.
Wow, billions. But it's not just about the quantity, right? I mean, you wouldn't want to train an AI on a bunch of blurry photos and grammatically questionable captions.
You're telling me. Data quality is huge, and get this. Researchers are now using AI to actually generate even better training data. They're using GPT-4 to create these really detailed, richer captions for images.
So it's like AI teaching AI to see better.
It's wild, right? It's like this AI bootstrapping process. But anyway, let's move on to that next training stage you mentioned, instruction tuning.
Right, instruction tuning. So we're moving beyond just association here. Now it's about following instructions, performing specific tasks.
Exactly. Instead of just recognizing a cat in a photo, it can understand and respond to a command like, describe that cat's expression.
Okay, I like where this is going. So how do they actually do that?
Well, the AI learns to process instructions given in natural language, just like you'd talk to me or anyone.
Gotcha. So what kind of data do they use for this stage?
Researchers are getting creative here,
Yep.
adapting existing datasets like visual question answering, or VQA for short, and they're even using, you guessed it, GPT to come up with even more complex and varied instructions for the MLLM to learn from.
So it's like giving the AI a set of tools and then showing it how to use those tools effectively in all kinds of different situations.
Exactly. And this is key. The more varied the instructions, the better the AI can handle new and unfamiliar tasks in the future. Think of it like learning a new language. The more you practice with different phrases and scenarios, the more fluent you become.
Makes sense. Okay, so we've laid the foundation with pre-training, honed those skills with instruction tuning. What's the final touch? You mentioned something called alignment tuning.
Ah, yes, alignment tuning. This is
Yeah.
where we fine-tune the AI's behavior. We want it to be accurate, short, but also contextually appropriate, aligned with human values.
So it's not enough for the AI to just spit out information. It needs to understand the nuances of how we communicate, the intent, the emotions, all of that.
All of it. It's a tall order. Techniques like reinforcement learning with human feedback, or RLHF, are really important here. It's basically having humans give feedback on the AI's responses, showing it what's considered helpful, appropriate, how to behave in the real world.
Like a coach, dieting the AI to that winning performance, helping it avoid awkward missteps or robotic responses.
Perfect analogy. And this alignment tuning is crucial to tackle a really important challenge with MLLMs: hallucinations.
Hallucinations. Wait, is the AI seeing things now?
Not exactly. It's more like, in the context of AI, hallucinations are when the AI generates a response that seems plausible, but it's actually fabricated.
It's like making things up.
Essentially, yeah. And that can be a problem, especially if you're relying on the AI for accurate info. The paper dives into these different types of hallucinations. There's existence hallucination,
Right.
where the AI might say something's in an image when it's not, or relationship hallucination, where it misunderstands how things in an image relate to each other.
Okay, yeah, that could lead to some serious misunderstandings. So how do they fix it?
It's an ongoing area of research, lots of different techniques being explored, but it's definitely a work in progress. But hey, that's AI research for you, always evolving.
That's true. But let's move on from the how and dive into the what. What can these MLLMs actually do? Give us the cool stuff.
You got it. We've talked about AI struggling with humor, right? Well, MLMs are showing real progress there. They can actually get the humor in a meme now, the cultural context, the sarcasm, all that.
So they can understand why that cat wearing a tiny cowboy hat is funny. That's a pretty high bar for AI. What else can these MLLMs do?
Well, get this. The paper talks about MLMs being able to understand not just an image as a whole, but specific regions within an image.
Okay, so like what do you mean? Give me an example.
Imagine pointing to a face in a crowded photo and asking the AI, what's this person's mood? And it actually gives you a reasoned response.
It's like having an AI detective by your side.
Exactly.
Okay, that's understanding. What about generating responses? Are we still stuck in the world of text-only replies?
Not at all. We're moving way beyond that. Imagine this. You ask an AI to create a children's story about a magical treehouse, and it generates not just the text, but accompanying illustrations in its own unique style.
Whoa, so we're talking AI storytellers and illustrators now. This technology is incredible.
It's pretty amazing.
But are there like real-world applications for this? I mean, beyond these fun, creative examples.
Absolutely. Let's take the field of medical imaging. MLLMs can analyze X-rays or scans, for example, and actually provide doctors with additional insights, potentially even leading to faster and more accurate diagnoses.
Wow. So from understanding memes to assisting doctors, the range here is incredible. But there have to be limitations, right? What are the researchers still trying to figure out?
Well, one of the big ones is getting MLLMs to process these longer sequences of information, Right now, they're great with shorter clips, images, things like that.
Short attention spans.
Kind of, yeah.
Yeah.
But analyzing a whole movie, like understanding the narrative flow, the emotional arcs, that's a whole other challenge. We're not quite there yet.
So, like, it's easy for them to watch a short YouTube clip, but a whole movie, forget about it. Something like that. And then there's the whole challenge of making them better at following those really complex, nuanced instructions.
Right. So right now, we're at the level of, like, find the cat. But we want to get to explain the cultural significance of cats in ancient Egypt using only emojis.
Okay, maybe not that complex, but you get the idea.
I do, I do. So what are some of the techniques that are actually driving this progress? Like, what's the secret sauce?
Well, one interesting one is called multimodal in-context learning, or MICL.
Catchy.
Right. But basically, instead of explicitly programming every little thing, you show the AI a few examples, and it learns to apply that same pattern to new, similar situations.
So like showing a budding chef how to make a few dishes, and then they can go off and create their own recipes.
Yeah, that's a great way to put it.
So show them, don't tell them. Got it. What else? Another one is multimodal chain of thought, or MCT. And that's all about getting the AI to, show its work, so to speak. It's not just about the answer, it's about revealing those reasoning steps along the way.
Transparency is always good.
Absolutely, especially with AI. And then the last one I'll mention is this idea of LLM-aided visual reasoning. And this is really interesting. This involves using LLMs as like the controlling intelligence behind even more complex AI systems.
So the LLM is like the conductor of an orchestra, bringing together all these different AI specialists to achieve this common goal.
Exactly. And that's where the real potential of MLLMs lies.
Yeah.
Building these AI systems that can not only understand the world, but can actually act on that understanding in these really sophisticated ways.
It's like we're on the cusp of this whole new era of AI, one that's less about lines of code and more about understanding the world as we experience it, through sight, sound, you name it.
It's an exciting time to be working in this field, that's for sure.
It sounds like it. Well, this has been an incredible deep dive into the world of multimodal large language models. The future is multimodal. At least it seems that way. Thank you so much for joining us on this thrilling exploration. And to you, dear listener, we'll be back next time with another deep dive into the world of cutting-edge technology. Until then, keep those questions coming and never stop exploring.